Hey everybody, we are here with question number 22 from our FRQ prep book, and this is coming from the 2004 B Calculus BC exam. So I think it's a pretty straightforward FRQ. Ordinarily would land itself on the AB one, except for some reason D is really complicated looking, and it's going to bring back an old friend that we haven't seen in a long time. So let's go and tackle this guy. I think we can do this. This is A. Find the average value of g on the function of the closed interval 1 to 4. When I hear the words average value, my first instinct is to go for 1 over b minus a times an integral. So, 1 over 4 minus 1, integral, sorry, not parentheses, 1 to 4. And that's going to be, I'm going to call him x to the negative 1/2. That's going to help me see the reversal of power rule better. So that's going to be, looks like x to the 1/2 times 2 times 1/3 on 1 to 4. Now, constants. I like constants, because constants, we all know what I like to do to constants. I like to kick them out. So I'm going to go ahead and say 4 to the 1/2 minus 1 to the 1/2. So that looks like it's going to be 2/3 times, looks like 2 minus 1, right? So 2 minus 1 is 1? Awesome. 2/3 is the answer. And I think we can wrap it up for A. That's all good. B. I think we're still in Calc AB land. It says, let S be the solid generated when the region bounded by the graph of f of x and the vertical lines x equals 1 and 4, and the x-axis is revolved about the x-axis. Find the volume of S. So, if you know what this graph looks like, it helps you out a little bit. But if you don't, it's not a huge deal. Mind you, this is not a graphing calculator problem, but if you've graphed enough of these, you kind of see that it kind of does one of these numbers. It's going to be chopped down by this vertical line, x equals 1 and x equals 4. Since we're rotating them about the x-axis, that makes it a dx integral that's solid, which means there's not going to be any outer radius minus inner radius. So it's a pretty straightforward rotational integral. So it's going to be looking like pi integral from 1 to 4 of x to the negative 1/2 squared dx. And again, I'm not going to use anything fancy. I don't have to use the shell method or anything like that. I'm going to go ahead and just, use my regular old Calc AB stuff. There is no need to show off here. So I'm going to go and not integrate him. I'll just do a little bit of algebra because I think that's going to help. So that's going to be x to the negative 1. So x to the negative 1 dx. Well, that one's pretty suspect right there. That's definitely not going to integrate into x to the 0 over 0. I know that it's going to be pi, and then the integral of x to the negative 1 is the same thing as the integral of 1 over x, which we all know. We're not going to fall for this, I know that, but I always like to hammer that home, because when you're in the zone, you might forget. And so from here, I think it just becomes pi, and then ln of 4 minus, ln of 1 is 0, so I'll just go and clip him off at 0. So I think we're good on this. I think there's nothing else to do with this problem here. Much ado about nothing. Alright, let's move on to part C. I'm going to scroll down just a little bit. It says, for the solid S given in part B, in other words, this answer right here, find the average value of the areas of the cross-sections perpendicular to the x-axis. Well, we already know that our volume is pi times ln of 4, right? That's going to be the volume, right? So if I want to find the area, the average value of the areas of the cross-sections perpendicular to the x-axis, well, the average value is just going to be this guy averaged out. So realistically, it just becomes pi times ln of 4 divided by 3. And there's really nothing else to it. They just want a slither of the cross-section, a slither of the average cross-section. And I think that's all there is for C. D. This is where things get a little bit thick. It says, the average value of the function on the unbounded interval a to infinity is defined by this guy. Show that the improper integral from 4 to infinity is divergent, but the average value from 4 to infinity is actually finite. So let's see how that works. Before I do that, I'm going to go ahead and clean this up a little bit, so give me a second. And we are back to a clean board. So from here, what they're basically saying is that the average value is defined by, technically this is 1 over b minus a times an integral which is being taken the limit of. This expression, at least barring the b minus a, should look somewhat familiar, or even this expression here with the g of x. Since we're moving towards infinity, this is an improper integral and needs to be treated as such. So what I'm going to do is I'm going to go ahead and say, alright, for part D, I'm going to go ahead and take the improper integral from 4 to infinity of g of x dx. So how do I do that? Well, that's going to be the limit, as in this case they're saying b goes to infinity. I'll keep it tried and true. As b goes to infinity of the integral from 4 to b of, I'll call them x to the negative 1/2 again. And what's that going to be? Well, that's going to be x to the 1/2, we've done this before, times 2 on the interval 4 to b, and again, I'm not going to forget the limit as b goes to infinity. I'm going to go ahead and kick this b out, the 2 out, so I'm going to say 2 times the limit as b goes to infinity, and I'll go ahead and just evaluate. I'll go ahead and say b to the 1/2 minus 4 to the 1/2. Now, as b goes to infinity, this guy will go to infinity, which means this dude right here diverges. Cool. We showed the first qualifier here. We showed that we're diverging. But let's find out what happens to the average value. So I know what you're thinking. How is it that the actual integral diverges, but the average version of it does not diverge? You figure the average of infinity is probably infinity, but who knows, we could be wrong. So from here, we'll do the same thing. We'll do 1 over b minus a, so that would be 1 over b minus a would be b minus 4 times the limit as b goes to infinity from 4 to b. Again, where I get this b on the outside from, it's the average value from b to 4 of x to the negative 1/2 dx. And again, we don't need to really see this part of the movie again, but I'll do it anyway. So 1 over b minus 4, consider it like a flashback, like in The Naked Gun, when, they did the whole, we haven't seen each other in a long time scene. It's not bad. That's a funny movie. It's going to be 2x to the 1/2 on 4 to b. This 2, that's a constant, I'll kick them out on the average value here. So I'm going to say 2 over b minus 4 times the limit as b goes to infinity of, looks like b to the 1/2 yet again, minus 4 to the 1/2 yet again. Now I'm going to do something that I rarely ever do. This constant here that exists on the outside, I'm actually going to kick him in. So I'm going to go ahead and say, or I'm going to kick him in partly. I'll say 2 times the limit as b goes to infinity of b to the 1/2 minus 2 over b minus 4. Now, forget about this 2 for a second. If I let b go to infinity, notice the dominant terms from the top and the bottom. The dominant terms are dictating that the bottom is larger, which means this guy actually goes to 0. Therefore, the average value of this improper integral is finite, even though the regular improper integral was divergent. So that's it for this FRQ. Again, somewhat straightforward, I think. But again, feel free to post in the comments. If you have any questions, let me know. I will get back to you guys. I hope you guys are doing well. I miss you guys. It would be more fun to do this in person with you, but unfortunately, this is where we are. So I will hopefully see you guys very, very soon. See you later.